there's something deeply unsettling about reality itself. Everything you've ever seen, every star in the night sky, every galaxy stretching across billions of light years, every atom inside your body, it all adds up to almost nothing. Not metaphorically, not philosophically, scientifically, because according to everything we can measure, all of it, light, matter, planets, black holes, only make up about 5% of what actually exists. The other 95% is completely invisible. We can't see it. We can't touch it. We don't know what it is, and yet it controls the structure of galaxies. It bends the fabric of space. It determines the fate of the entire universe, which means everything you think is real is only a tiny fraction of reality. If that idea feels a little unsettling, that's because it should, because tonight we're going to explore the part of the universe that we don't understand at all. And if you enjoy slow, deep journeys into the unknown, consider subscribing and leaving a like. It helps this quiet corner of the universe keep expanding. Now, let's begin with something simple, or at least something that feels simple, what we call reality. Part 1. The 5% illusion. Look around you, not quickly, not as a passing glance, but slowly. Take in the edges of the room, the subtle way light rests on surfaces, the quiet presence of objects that feel solid, dependable, real. Your hands, the air, the ground beneath you, it all feels certain, stable, almost unquestionable. For most of human history, that feeling was enough. Reality was what we could see, what we could touch, what we could measure with our senses. And for a long time, that seemed to work. We mapped the stars, tracked the motion of planets, discovered the laws that govern motion, gravity, energy. We built a picture of the universe that felt complete, elegant, understandable. But then, as our tools became more precise, as our observations reached further into space, something strange began to appear. Small inconsistencies at first, tiny mismatches between what we expected and what the universe actually did. Galaxies were rotating too fast, stars at the edges, moving in ways that didn't make sense. According to everything we knew, they should have flown apart, but they didn't. Something was holding them together, something invisible. At first, scientists assumed there must be more matter we simply hadn't seen yet. Maybe faint stars, cold gas, dust clouds hidden in the dark. But no matter how carefully they looked, it wasn't enough. There simply wasn't enough visible mass to explain what was happening, which led to a quiet, unsettling conclusion. There must be something else out there. Something we cannot see, but whose gravity is unmistakably real. They gave it a name, dark matter, not because they understood it, but because they didn't. It was matter. That was dark, invisible, undetectable by light, but present everywhere. And suddenly, the universe didn't feel so simple anymore, because if galaxies, vast, ancient structures were being shaped by something we couldn't observe, then what else were we missing? As the data continued to come in, the picture became even stranger. When scientists tried to map how much dark matter there should be, they found something shocking. All the stars, all the planets, all the gas and dust, everything we can see accounts for only about 5% of the total mass and energy of the universe. 5%. Which means 95% of reality is made of something else. Pause for a moment and let that sink in. Imagine reading a book And realizing you only understand 5% of the words, imagine listening to a conversation where 95% is in a language you've never heard. Imagine living your entire life inside a world that is almost entirely hidden from you. That is not science fiction, that is our current understanding of the universe. And yet, we don't feel it, not directly. You don't wake up in the morning and sense dark matter flowing through your room. You don't feel the invisible structures holding entire galaxies together. It's silent, subtle, completely beyond human perception, but it's there, right now, passing through you, through the earth, through everything. And that raises a question that is both simple and deeply unsettling. If most of reality is invisible, then what exactly are we experiencing? The answer begins with light, because everything we see, everything we call visible, exists within a tiny slice of the electromagnetic spectrum, a narrow band that human eyes evolved to detect. But beyond that band, there is so much more. Radio waves, infrared, ultraviolet, X-rays, gamma rays, entire layers of reality that exist all around us but remain completely unseen. And even those are still part of the 5%, which means even when we expand our vision with telescopes, satellites, advanced detectors, we are still only observing a small fraction of what's out there. It's like standing in a vast ocean and only being able to see the surface, calm, reflective, familiar, while beneath there are currents, structures, unknown depths that shape everything above. Dark matter is like those hidden currents. We can't see it directly, but we see what it does. We see galaxies bending, light curving, structures forming, as if guided by something unseen. And so, modern cosmology became something very different from what it once was. No longer a study of what we can observe, but a study of what we can infer, what we can deduce from the shadows cast by invisible things, which is both beautiful and unsettling, because it means the universe is not just stranger than we imagined, it is stranger than we can directly experience. And that changes something fundamental, not just about science, but about perception. Because for most of human history, we trusted our senses. We believed that what we saw was what existed. But now, we know that's not true. What we see is only a thin layer of a much deeper reality. A reality that is mostly hidden, mostly unknown, and possibly completely different from anything we've ever imagined. So the next time you look up at the night sky and see the stars scattered across the darkness, try to remember this. You are not looking at the universe, you are looking at a small, glowing fragment of it, a thin layer of light floating on top of something vast and invisible. And as we move forward into the deeper parts of this journey, we'll begin to explore that hidden 95%, what it might be, how it shapes the cosmos, and why, even now, it refuses to reveal itself. Because the deeper we look, the clearer it becomes that the greatest mystery of the universe is not what we can see, but what we can't. Part 2. The invisible structure. If 95% of the universe is invisible, then the question becomes, where is it? Because it's one thing to say something exists. It's another to understand how it shapes everything around us. Imagine for a moment that you could remove all the visible matter in the universe. Every star, every planet, every glowing nebula, gone. What would remain would not be empty space. Instead, you would see something astonishing, a vast, intricate web stretching across unimaginable distances, threads, filaments, clusters, all composed of something you cannot see. This is what scientists call the cosmic web. It is the large-scale structure of the universe, and it is not built from light, but from darkness. Galaxies, including our own Milky Way, are not randomly scattered. They are arranged along these invisible filaments, like dewdrops, resting on strands of a spider's web, which means the universe is not shaped by what we see. It is shaped by what we don't, and that changes everything. Because for a long time, we assumed gravity came from visible matter, stars pulling on stars, galaxies pulling on galaxies, a simple, elegant interaction. But when scientists began mapping the motion of galaxies, they discovered something strange. They weren't just moving. They were following paths that traced out structures that shouldn't exist. If only visible matter were involved. It was as if there was a hidden framework, a skeleton, holding the universe together, and galaxies were simply forming, where this invisible structure allowed them to. Think of it like this. Imagine walking into a dark room, filled with invisible scaffolding. You can't see the beams, you can't touch them, but you notice that objects are arranged in specific patterns, suspended, aligned, connected, as if guided by something unseen. That's what astronomers began to realize. The universe wasn't random, it had architecture, and that architecture was made of dark matter. But here's where it becomes even more unsettling. Because dark matter doesn't just sit there, it moves, it flows, it evolves. In the early universe, shortly after the Big Bang, everything was almost uniform, a hot, dense, glowing sea of particles, but within that sea, there were tiny fluctuations, barely noticeable differences in density, and over time, those tiny differences grew, not because of visible matter, but because of dark matter. While normal matter interacted with light, collided, scattered, radiated energy, dark matter did something very different. It remained quiet, cold, unaffected by radiation, which allowed it to begin forming structures, earlier than anything else but invisible clumps, gradually pulling more matter toward them, building the first gravitational wells. And then, as the universe cooled, normal matter began to fall into those wells. Stars ignited, galaxies formed, light emerged. But only where dark matter had already prepared the stage, which means everything we see today is built on something we cannot see. Every galaxy, every cluster, every vast cosmic structure exists because dark matter was there first. It's like watching a play and only seeing the actors, while the stage, the lighting, the entire structure behind the performance remains hidden, and yet, without it, nothing would exist. This leads to a strange realization. Dark matter is not just part of the universe, it is the foundation of it. Without dark matter, galaxies would not form, stars would not cluster, planets, including Earth, would likely never exist, which means you are here because of something that you cannot perceive. Let that settle in. Your existence may depend on an invisible substance that passes through you every second without leaving a trace. And it does pass through you right now. Dark matter does not interact with your body. It doesn't collide with your atoms the way normal matter does. It simply moves through, quietly, constantly. Billions of particles streaming through your body every moment. And you feel nothing. No sensation, no awareness, just silence. Which raises another question. If dark matter is everywhere, why is it so difficult to detect? The answer lies in how it behaves. Unlike normal matter, dark matter does not emit light, it does not absorb light, it does not reflect light. It is completely invisible across the entire electromagnetic spectrum, which means no telescope, no camera, no sensor designed to detect light can ever see it directly. The only way we know it exists is through gravity, through the way it pulls on things we can observe, through the distortions it creates in the fabric of space. One of the most powerful examples of this is something called gravitational lensing. When light passes near a massive object, its path bends. This effect, predicted by Einstein, allows us to see mass, even when that mass is invisible. And when astronomers observe distant galaxies, they often see their light stretched, warped, distorted in ways that reveal huge concentrations of unseen mass, mass that cannot be explained by visible matter alone. It's like seeing shadows without knowing what is casting them. You don't see the object, but you know it's there because of what it does. And everywhere we look, the same pattern appears. More gravity than we can account for. More structure than we can explain. A universe that behaves as if something invisible is holding it together. And yet, despite decades of research, we still don't know what dark matter actually is. Not its composition, not its origin, not its true nature. Only its effects, which places us in a very unusual position. We are living inside a structure we cannot see, shaped by forces we do not understand, dependent on something we cannot directly detect. And as we continue this journey, the mystery deepens, because dark matter is only part of the story. There is something else, something even more elusive, even more powerful, something that is not pulling the universe together, but pushing it apart. And unlike dark matter, this force does not build structure. It destroys it, slowly, silently, relentlessly. In the next part, we begin to explore that force, the one that is stretching space itself, and quietly determining the ultimate fate of everything that exists. Part 3. Something is pushing the universe. There is a quiet assumption that most of us carry without realizing it, that gravity is always pulling things together. Planets orbit stars, stars gather into galaxies, galaxies form clusters, everything drawn inward for centuries. That idea held true. Gravity was the architect of the cosmos, the force that shaped structure, brought order, created everything we see. And for a long time, scientists believed that gravity would also decide the ultimate fate of the universe. There were only a few possibilities. If there was enough matter, gravity would eventually slow the expansion of the universe, stop it, and pull everything back inward, a cosmic collapse, the Big Crunch. If there wasn't enough matter, expansion would continue forever, but gradually slow down. As gravity resisted the motion, two outcomes, both governed by the same force. Gravity, pulling, resisting, shaping destiny. But then, In the late 20th century, something unexpected happened. Astronomers began studying distant supernovae, exploding stars so bright they can be seen across billions of light years. These explosions act like cosmic markers, standard candles, allowing scientists to measure distances across the universe. And by comparing those distances with how fast galaxies are moving away from us, they hope to determine how the expansion of the universe was changing over time. Was it slowing down, as gravity suggested it should? At first, that seemed like a reasonable expectation, but the data told a different story. The farther away the supernovae were, the dimmer they appeared, which meant they were farther than expected. And that could only mean one thing. The universe wasn't slowing down, it was speeding up. Pause for a moment, because this is where everything changes. The expansion of the universe is not just continuing, it is accelerating. Galaxies are not just drifting apart, they are moving away from each other, faster and faster over time, as if something is pushing them, something that works against gravity, something that doesn't pull, but repels. At first, scientists were skeptical. The result was so unexpected, so completely opposite to everything we thought we knew, that many assumed there must be an error. But as more observations came in, from different teams, different telescopes, different methods, the conclusion became unavoidable. The universe is accelerating, and whatever is causing this is everywhere, filling space itself. They gave it a name: dark energy. Not because they understood it, but because they needed to call it something. And just like dark matter, the name hides a deeper truth. We don't know what it is, only what it does. But what it does is extraordinary. Dark energy makes up roughly 70% of the universe, which means it is the single largest component of reality, more than all visible matter, more than all dark matter combined. And unlike dark matter, which pulls things together, dark energy does the opposite. It pushes space apart, not objects through space, but space itself, stretching it, expanding it. Imagine drawing two dots on a balloon. As you inflate the balloon, the dots move away from each other, not because they are moving across the surface, but because the surface itself is expanding. That is what dark energy is doing everywhere, at every moment. And the more space expands, the more dark energy there is, which leads to a strange feedback loop. Expansion creates more space. More space contains more dark energy. More dark energy drives faster expansion, and so the universe accelerates, quietly, relentlessly, without pause. This raises a profound question. If dark energy is getting stronger, what happens in the distant future? At first, the effects are subtle. Galaxies drift further apart. The night sky becomes darker. Distant galaxies fade beyond the reach of our telescopes. Eventually, only our local group of galaxies remains visible. Everything else slips beyond the observable horizon. The universe becomes isolated. But it doesn't stop there. If acceleration continues, structures themselves begin to break apart. Galaxies pulled apart, stars drifting away from each other, planets unbound from their orbits. In the most extreme scenario, even atoms could be torn apart, a future known as the Big Rip, where the expansion of space becomes so powerful that nothing can hold together, not matter, not energy, not even the fabric of reality as we know it. Now, it's important to pause here, because this is only one possibility. We don't yet know if dark energy will remain constant, grow stronger, or change over time. But the fact that this scenario is even possible tells us something important. We are not in control of the universe's fate. We are passengers in a system driven by forces we barely understand, and those forces are not just abstract ideas. They are shaping reality right now. The space between galaxies is stretching. Light traveling across the universe is being stretched with it. Wavelengths lengthen, energy decreases. A phenomenon known as redshift, which is how we first realized that the universe is expanding at all. But now, that redshift carries a deeper message, not just that space is expanding, but that something is accelerating that expansion. Something built into the fabric of the cosmos itself. And here is where the mystery deepens, because dark energy doesn't behave like anything we've ever encountered. It doesn't clump, it doesn't form structures, it doesn't interact in any familiar way. It is smooth, uniform, the same everywhere, which suggests it may not be a thing at all, but a property of space itself, a kind of energy inherent to the vacuum, empty space that isn't truly empty, but filled or with something that pushes outward. If that idea feels strange, that's because it is, because it challenges one of our deepest intuitions, that nothing means nothing. But in modern physics, nothing may be one of the most powerful things in existence. And so now we find ourselves in a universe defined by two invisible forces: dark matter holding structures together, dark energy pulling them apart, a balance between attraction and expansion, between structure and dissolution. And somewhere in the middle of that balance is everything we know: galaxies, stars, planets, life, all existing in a narrow window between two unknowns, which leads to a quiet but profound realization. We are not living in a universe that is stable. We are living in a universe that is evolving, shaped by forces we cannot see, moving toward a future we cannot fully predict. And as we continue this journey, the questions become even deeper, because understanding what dark energy does is only the beginning. The real mystery is this: why does it exist at all? And why does the universe allow it? In the next part, we begin to explore one of the most unsettling ideas in modern physics, that empty space may not be empty, and that the vacuum itself could hold the key to everything we don't understand. Part 4, the energy of nothing. There is an idea so strange that at first it feels almost impossible to accept. That empty space is not empty, not truly. When we imagine nothing, we picture a void, still, silent, completely blank. No particles, no light, no structure, just absence. But modern physics tells a very different story. Because even in the most perfect vacuum we can create, where every atom has been removed, where every particle has been cleared away, something remains. A quiet, restless activity, not visible, not tangible, but real. At the smallest scales, space itself begins to behave strangely. Instead of being smooth and still, it becomes unstable. Tiny fluctuations, appearing and disappearing constantly. Particles that flicker into existence and vanish almost instantly. This is not science fiction. It is a prediction of quantum physics, a field that describes reality at the smallest possible scales, where certainty breaks down and probability takes over. In this realm, nothing is not stable. It cannot remain empty. Because the laws of quantum mechanics allow for brief violations of energy conservation. Energy can appear, borrowed from the vacuum itself, as long as it disappears quickly enough. And so, space becomes alive with temporary particles. They emerge in pairs, particle, antiparticle. They exist for a fraction of a second, and then they annihilate each other, returning everything back to nothing. But this process never truly stops. It happens everywhere, all the time, even in the emptiest regions of the universe, which means the vacuum is not empty. It is filled with potential, with energy, a subtle, persistent energy that exists even when nothing else does. This is known as vacuum energy. And it may be the key to understanding dark energy. Because if empty space contains energy, then as the universe expands and more space is created, more of this energy appears, not because something is being added, but because space itself carries it. And if that energy has a repulsive effect, if it pushes outward, then it could explain why the universe is accelerating. Dark energy may simply be the energy of empty space, a property of the vacuum itself. At first, this idea seems elegant, simple, almost satisfying. But then, a problem emerges, a very large problem. When physicists try to calculate how much energy should exist in the vacuum, using quantum theory, they arrive at a number that is unimaginably large, so large that, if it were true, the universe would have expanded so rapidly that galaxies could never have formed, stars would not exist, planets would not exist, life would not exist, and yet, here we are. Which means something is wrong. Either our understanding of quantum physics is incomplete, or our understanding of gravity is incomplete, or both. This mismatch between theory and observation is one of the greatest unsolved problems in physics, sometimes called the worst prediction in the history of science, because the difference between what we calculate and what we observe is not small. It is off by a factor of 10 to the power of 120. A number so large, it is almost meaningless to comprehend. It's like predicting the weight of a grain of sand and getting the mass of an entire galaxy. Something is deeply wrong, and no one knows why. This leads to a quiet, uncomfortable possibility that we are missing something fundamental, not just a detail, not just a variable, but a core piece of reality itself. Something about space, about energy, about existence that we do not yet understand. And this is where the mystery deepens even further. Because if vacuum energy is real, and if it drives the expansion of the universe, then empty space is not passive, it is active, dynamic, capable of shaping the cosmos, which challenges one of our deepest intuitions, that something is required to create change. But here, change arises from nothing, from the structure of space itself. And if that's true, then the vacuum is not just a background, it is a participant, a force, perhaps even a foundation. And that raises an even more unsettling question. If empty space has energy, where did that energy come from? Was it always there? Did it emerge at the beginning of the universe? Or is it something deeper, more fundamental than the universe itself? Some theories suggest that the vacuum we experience is not the lowest possible energy state, that there may be a deeper level, a more stable vacuum. And that, what we call empty space, is only temporarily stable, a false vacuum. If that were true, then the universe, as we know it, could change instantly, without warning. A transition to a lower energy state would release enormous energy, altering the laws of physics, reshaping reality itself, not gradually, but all at once. A bubble of true vacuum, expanding at the speed of light and erasing everything in its path before we could even perceive it. Now, there is no evidence that this will happen, but the fact that it is possible, within our current understanding of physics, is enough to give pause, because it means the stability of reality may not be guaranteed. It may be contingent, dependent on conditions we do not fully understand. And so, we find ourselves in a universe where even nothing is not simple, where emptiness contains energy, where silence hides activity, where the vacuum itself may hold the key to the expansion of the cosmos. And yet, despite all of this, we still don't know what dark energy truly is. We don't know why vacuum energy behaves the way it does. We don't know why the universe allows it, only that it exists and that it is shaping everything, which brings us to a deeper realization. The more we study the universe, the more we discover that the most important forces are the ones we cannot see. Dark matter, building structure, dark energy, driving expansion, vacuum energy, emerging from nothing, all invisible, all fundamental, and all still unexplained. In the next part, we move even closer to the edge of understanding. Because if most of reality is invisible, and if even empty space contains energy, then the question is no longer just what exists, but how much of reality are we truly capable of understanding, and whether there are limits to what the human mind can ever know. Part 5. The limit of understanding. There is a quiet assumption that sits beneath everything we've explored so far, that if we keep searching, keep measuring, keep building better instruments, we will eventually understand the universe, that every mystery, no matter how strange, will one day be explained. But what if that isn't true? What if there are limits, not just to what we can observe, but to what we can ever understand? Because the deeper we look into reality, the more we encounter something unexpected, not just complexity, but boundaries, invisible edges, where our current theories stop working, where equations begin to break down, where intuition fails completely. Take quantum physics. At the smallest scales, particles don't behave like objects. They don't have fixed positions. They don't follow clear paths. Instead, They exist as probabilities, waves of possibility that only become definite when observed, which leads to a strange conclusion. That reality, at its most fundamental level, is not fully determined, but influenced by observation itself. This is not just philosophical, it is measurable. Experiments have confirmed it again and again, and yet no one fully agrees on what it means, because it challenges something deep in how we understand the world, that things exist independently of us. But in quantum mechanics, that independence becomes unclear. Does a particle have a position before we measure it? Or does the act of measurement bring that position into existence? There is no single answer, only interpretations. Different ways of describing the same equations. Some suggest all possibilities exist at once, branching into multiple realities. Others suggest that observation collapses reality into a single outcome. And some suggest that we are simply missing something deeper, a hidden layer of reality that would make everything make sense. But so far, no interpretation has been proven more correct than the others, which leaves us in a strange position. We can predict outcomes with incredible accuracy, but we don't fully understand what those predictions mean. It's like having a map that perfectly guides you to your destination without knowing what the landscape actually looks like. And this is not the only place where we encounter limits. Consider gravity, one of the most familiar forces in the universe. We understand how it works on large scales. Planets orbit stars, galaxies move through space. Einstein's theory of general relativity describes this beautifully. Gravity as the curvature of space-time, mass bending the fabric of reality. But when we try to apply that same theory at the smallest scales, it stops working. The equations break down. They produce infinities, results that have no physical meaning, which means we do not yet have a theory that unifies gravity with quantum mechanics. Two pillars of modern physics, both incredibly successful, both experimentally verified, and yet incompatible. It's as if we have two separate descriptions of reality, each accurate within its own domain, but unable to connect. And somewhere between them is a gap, a missing piece, a deeper level of understanding that we have not yet reached. This is one of the greatest goals in physics, to find a theory of everything, a single framework that explains all forces, all particles, all interactions. But despite decades of effort, we are not there yet. And some physicists have begun to wonder if we ever will be. Because each time we push further, the questions don't get simpler. They become more abstract, more disconnected from everyday experience. String theory, extra dimensions, quantum gravity, ideas that stretch the limits of imagination itself. And yet, still no definitive answers, which leads to a difficult possibility that the universe may not be fully understandable, at least not in the way we expect, because our brains evolved to survive, to navigate environments, to recognize patterns that help us stay alive, not to comprehend the deepest structure of reality. And so, there may be concepts that exist beyond our intuitive grasp, Not because they are impossible, but because we are not equipped to fully understand them, just as a fish cannot comprehend the sky, or an ant cannot understand a city. There may be aspects of the universe that lie beyond our cognitive reach, and yet we continue to try. We build instruments that extend our senses, telescopes that see deeper into space, detectors that measure invisible particles, experiments that probe the smallest scales, and with each step we uncover more, but we also uncover more mystery, more questions, more uncertainty, which suggests something profound. That knowledge does not eliminate mystery, it expands it. The more we learn, the more we realize how much we don't know. And perhaps that is not a failure, but a fundamental feature of reality itself. Because if the universe were simple, if it could be fully understood with a single set of equations, then the journey would end. There would be nothing left to explore, no more questions, no more wonder. But that is not the universe we live in. We live in a universe where the deeper we go, the more it resists complete understanding, where every answer leads to new questions, where certainty is always just out of reach. And yet, there is something strangely beautiful about that, because it means the mystery is not temporary, it is permanent, a part of the structure of reality itself. And as we continue this journey, we begin to approach an even more unsettling idea. Not just that we don't understand the universe, but that the universe may not be built to be understood. In the next part, we explore the strange possibility that reality itself may be hiding its true nature, not by accident, but by design. Part 6. The experiments that found nothing. There is something quietly frustrating, more about trying to understand the universe, because sometimes the more carefully you search, the less you find. And nowhere is that more true than in the search for dark matter. By now, we have overwhelming evidence that it exists. Galaxies rotate too fast, light bends in impossible ways, the cosmic web holds together, as if something invisible is shaping it. But when it comes to actually detecting it directly, everything changes. Because for decades, scientists have been trying to catch dark matter in the act, not by observing galaxies, not by mapping gravity, but by detecting a single interaction, one tiny collision between a dark matter particle and normal matter, something small, something measurable, something undeniable. And so they began to build experiments, not on the surface, but deep underground, beneath mountains, inside mines, hidden far from cosmic radiation. Places where the noise of the universe is reduced to almost nothing, so that even the faintest signal could be detected. Imagine a vast chamber filled with ultra-pure liquid, xenon, argon, substances chosen, because they are incredibly sensitive to tiny disturbances. At the center, delicate detectors, waiting, silent, watching. The idea is simple. If a dark matter particle passes through and happens to collide with one of the atoms in the detector, it would produce a tiny flash, a faint signal, just enough to say something was here. Experiments like these have been running for years, constantly, patiently, waiting for a signal, and sometimes they do see something, a flicker, a disturbance, a possible interaction, but each time, after careful analysis, the result fades, explained by background noise, known particles, statistical fluctuations, not dark matter. Again and again and again. Nothing. And this is where the mystery deepens, because we are not searching blindly. We have theories. For a long time, the leading candidates were particles known as WIMPs, weakly interacting massive particles. The idea was elegant: a particle with mass that interacts through gravity but barely interacts with normal matter. Exactly what dark matter seemed to be. And according to many theories, these particles should be detectable, not easily, but eventually. And so, experiments were designed, specifically to find them. Larger detectors, more sensitive instruments, longer observation times. And yet, still, nothing. WIMPs have not been found. Not in underground detectors, not in particle accelerators, not in cosmic observations, and slowly, quietly, confidence began to shift. Maybe dark matter is not what we expected. Maybe it's not made of WIMPs. Maybe it's something else entirely, something even harder to detect. This is where the search begins to change. New ideas emerge, axions, tiny, almost massless particles that barely interact with anything, so elusive that detecting them would require entirely new kinds of experiments. Others suggest dark matter may not be a particle at all, but something more exotic: primordial black holes, ancient remnants, formed in the earliest moments of the universe, invisible, but massive enough to influence gravity, or even more radically. Some physicists have begun to ask whether dark matter exists at all, not because the evidence disappears, but because our interpretation might be incomplete. Maybe gravity itself behaves differently at large scales. Maybe the laws we rely on are not universal. Ideas like modified Newtonian dynamics attempt to explain the observations without dark matter. But these theories struggle to explain everything. And so, the mystery remains. We see the effects. We measure the influence. We map the structure. But we cannot find the source. It's like hearing footsteps in an empty room, clear, consistent, unmistakable. But when you look, there is no one there. And that creates a tension, because science depends on detection, on evidence, on the ability to observe and confirm. But here, we are faced with something that reveals itself only indirectly, through gravity, through structure, through motion, never directly. And that forces us into an uncomfortable position. We must accept that something exists without ever touching it, without ever seeing it, only by observing what it does to everything else. This is not entirely new. In the past, we discovered Neptune, not by seeing it first, but by noticing its effect on the orbit of Uranus. We inferred its existence before we confirmed it, but eventually we saw it. With dark matter, that moment has not come, and may not come, for a very long time, or perhaps not at all, because there is another possibility. That dark matter interacts so weakly, so rarely, that detecting it directly may be beyond our technological reach. Not just today, but ever. And if that's true, then we are left with a strange reality. We are living in a universe where the majority of matter is fundamentally invisible and possibly undetectable, not because it isn't there, but because it does not interact in ways we can measure. Which leads to a deeper question. What does it mean to understand something that you can never directly observe? Can we truly say we know it? Or are we constructing a model, a shadow, based on indirect evidence? And if so, how accurate is that shadow? This is where science becomes not just a process of discovery, but an exercise in humility. Because every time we build a detector and find nothing, we are reminded of how little we truly understand. And yet, we keep searching, building larger experiments, going deeper underground, listening more carefully to the quietest signals. Because even in the silence, there is meaning. Every non-detection rules something out, narrows the possibilities, guides us toward a better understanding. Even if that understanding is still far away. And so, the search continues. Quiet, patient, uncertain, because somewhere within that 95%, there is an answer, a structure, a particle, a principle, something that explains why the universe behaves the way it does. And until we find it, we are left in a strange position, surrounded by something that shapes everything, but refuses to reveal itself. In the next part, we move beyond detection and begin to explore a deeper possibility that the problem may not be what we're looking for, but how we're looking at reality itself, and whether our understanding of physics is missing something even more fundamental. Part 7, the map that doesn't match reality. There is something we rarely question because it feels so natural, that the models we build reflect reality itself. We draw equations, we simulate galaxies, we map the universe, and we assume that what we're seeing is what truly exists. But what if our models are not reality? What if they are only approximations, shadows of something deeper? Because when scientists simulate the universe using everything we think we know, something strange happens. The large-scale structure matches almost perfectly. The cosmic web forms, filaments stretch across space, galaxies cluster exactly where we expect them to. It's beautiful, elegant, convincing, almost too convincing, because when we zoom in to smaller scales, the picture begins to break. Galaxies don't behave exactly as predicted. Some rotate differently. Some form structures that shouldn't exist. Others are missing entirely. This is known as the small-scale crisis, a subtle mismatch between our simulations and reality, not large enough to dismiss the model, but not small enough to ignore. It's like having a map that perfectly shows continents, but gets the cities wrong. You can navigate broadly, but the details don't quite line up. And that raises a difficult question. Is the problem with the universe, or with our understanding of it? Because our simulations depend on assumptions about dark matter, about gravity, about how matter behaves over time. And if any of those assumptions are slightly off, the results will be slightly wrong. At first, scientists tried to fix the details. Adjust parameters, refine models, include more complex physics, and sometimes that helped, but not completely. The discrepancies remained, persistent, unresolved, which led to a deeper possibility that the problem is not just in the details, but in the foundation. That something about our model of reality is incomplete, or even incorrect. This is not the first time this has happened. In the past, we believed that Earth was the center of the universe, and our models worked for a while. But as observations improved, the inconsistencies grew, until eventually we realized the model itself had to change, not just adjusted, replaced. And now, some physicists wonder if we are at a similar moment, not with Earth at the center, but with dark matter and gravity. Because if dark matter cannot be detected, if experiments continue to find nothing, if simulations continue to struggle, then we must consider an uncomfortable possibility that our interpretation is wrong, not the observations. Those are real. Galaxies do rotate too fast. Light does bend in unexpected ways. The universe does have structure. That requires explanation. But the explanation itself may not be what we think. One alternative is that gravity behaves differently at very large scales, that the equations we use are incomplete, that there is a modification, a correction that we have not yet discovered. This idea has been explored. Theories like modified Newtonian dynamics, attempt to explain galaxy rotation without dark matter. And in some cases, they work surprisingly well, but they struggle with larger structures, galaxy clusters, the cosmic web, where dark matter models still provide better explanations, which leaves us in a strange position. Two incomplete ideas. One that explains large scales well but fails at detection, another that explains certain observations but fails at others. Neither fully satisfying, neither complete. And this is where the tension grows, because science prefers clarity, a single model, a unified explanation. But here, we have fragments, pieces of a puzzle that don't quite fit together. And yet, each piece seems necessary, which suggests that we are missing something, a deeper layer, a new principle, something that connects these ideas in a way we have not yet seen. And this is where things become even more interesting, because some physicists have begun to ask a more radical question. What if the problem is not with matter or with forces, but with space itself? What if space is not what we think it is, not an empty stage where events unfold, but something more complex, something that has structure, properties, behavior, something that can influence matter in ways we don't yet understand? If that were true, then dark matter might not be a substance at all, but an effect, an emergent property of how space behaves on large scales. And if that sounds strange, that's because it is. But so was the idea that time could slow down, or that space could curve, or that particles could exist in multiple states at once. Every major shift in physics has required us to rethink something fundamental. And now we may be approaching another one, a moment where the map no longer matches the territory, where our models are close but not complete. And where the next breakthrough will not come from refining what we know, but from questioning it deeply. Because if the universe is not behaving as expected, then perhaps it is not the universe that needs to change, but our understanding of it. And that realization is both unsettling and exciting, because it means we are not at the end of discovery. We are at the edge of it, standing just before a shift that could change everything. In the next part, we move even deeper into that possibility, exploring the idea that reality itself may not be as solid as it appears, and that what we call space may be something far more mysterious than we've ever imagined. In part 8, when space stops being empty, there is a quiet assumption that has followed us through everything so far, that space is simply there, a passive background, a stage where matter moves, where forces act, where events unfold. But what if that assumption is wrong? What if space is not empty, not passive, not even fundamental? Because as physics has advanced, a strange idea has begun to emerge, that space itself may be something that can change, not just expand, as we've already seen, but behave, respond, even break. At first, this sounds abstract, but there are moments in physics where space stops acting like a smooth fabric and starts behaving like something else entirely. Consider black holes. At the edge of a black hole, something extraordinary happens. Space and time are stretched to their limits. Gravity becomes so intense that the curvature of space-time approaches infinity, and at the center, according to our equations, everything breaks, a singularity. A point where density becomes infinite, where the known laws of physics no longer apply. This is not just a technical problem, it's a signal that our understanding of space is incomplete. Because if space can reach a point where our equations fail, then space may not be fundamental, it may be something that emerges from a deeper layer, something more basic, more fundamental, hidden beneath what we perceive. And this idea is beginning to take shape in modern physics. Some theories suggest that space is not continuous, not smooth, but made of tiny, discrete units, almost like pixels in a digital image, at scales far smaller than anything we can observe. Space may have a structure, a kind of grain, and what we perceive as smooth is simply the result of looking at a resolution too low to see the details. If that's true, then space is not empty. It is built, constructed from something deeper. And that raises a powerful question. What is space made of? Some physicists propose that space emerges from information, not matter, not energy, but relationships, connections between fundamental units that define how reality behaves. In this view, the universe is not made of things, but of interactions, a vast network where space itself is a byproduct of deeper connections, and distance is not a fundamental property, but something that emerges from how strongly things are connected. If that sounds strange, that's because it is. But it also explains something curious. Why space can stretch, why it can bend, why it can expand. Because if space is not fundamental, then it is not fixed. It can change. Just like any other emergent property, temperature emerges from the motion of particles. Waves emerge from interactions in a medium. And perhaps space emerges from something deeper, which brings us back to dark energy. Because if space itself has properties, then the expansion of the universe may not be driven by a mysterious substance, but by the behavior of space itself, a natural consequence of how it is constructed. And suddenly, the picture begins to shift. Dark matter, dark energy, vacuum energy. These may not be separate mysteries, but different expressions of the same underlying reality, a deeper structure that we are only beginning to glimpse. And this idea leads to something even more unsettling. Because if space is emergent, then what we perceive as location may not be fundamental. Distance may not be absolute. Even the idea of here and there may be more flexible than we imagine. In some theories, 2 points in space that appear far apart may actually be closely connected at a deeper level through hidden structures, shortcuts, not visible in our everyday perception. This is not science fiction. It arises naturally in certain models of quantum gravity, where space-time itself is woven from deeper connections. And if that's true, then reality is not what it appears to be. Not a smooth, continuous expanse, but a constructed experience, a projection of something more fundamental. And this raises a deeply unsettling possibility that what we perceive as reality is only an approximation, a simplified version of something far more complex, like seeing a shadow and assuming it is the object, or watching waves and forgetting the ocean beneath. We experience space as continuous, as stable, as real. But at deeper levels, it may be none of those things. It may be dynamic, discrete, emergent. And if that's true, then many of the mysteries we've explored may not be separate problems, but symptoms of a deeper misunderstanding. We are trying to explain the universe using concepts that may not be fundamental. Matter, space, energy. These may not be the true building blocks, but the visible surface of something deeper. And that is both exciting and unsettling, because it means we are not just missing details, we may be missing the entire foundation. And yet, despite this uncertainty, we continue to build models, to test ideas, to push the boundaries of what we can understand. Because even if reality is more complex than we imagine, it is not completely beyond reach. Every experiment, every observation, every theory brings us a little closer, not to complete understanding, but to a better approximation, a clearer shadow. And as we continue this journey, we begin to approach an even deeper question. If space is not fundamental, then what about time? And is it also an emergent property, something that arises from deeper processes? Or is it something more, something even stranger than space itself? In the next part, we explore the nature of time and why it may not flow in the way we believe it does. Part 9, the illusion of time. There is something about time that feels undeniable. You feel it moving, moment by moment, second by second, from the past, through the present, into the future. It feels like a river flowing in one direction, always forward, never backward, But what if that feeling is an illusion? Because when we look deeper into the laws of physics, something strange begins to appear. There is no rule that says time must flow forward. At the fundamental level, most equations work the same, whether time moves forward or backward. The motion of particles, the interactions of forces, the structure of physical laws, they are symmetrical, which means there is no preferred direction of time, and yet we experience one, clearly, unavoidably. So where does that direction come from? Why does time seem to move only one way? The answer begins with something simple: entropy, a measure of disorder, or more precisely, the number of ways a system can be arranged. And there is a rule that governs entropy. It tends to increase, always. A glass shatters, but never unshatters. Smoke spreads into the air, but never gathers itself back into a perfect shape. Heat flows from hot to cold, but never spontaneously reverses. These processes define the arrow of time, the direction we experience, from order to disorder, from simplicity to complexity. And this gives time its sense of flow. But here's the deeper question. Why does entropy increase? Why did the universe begin in a state of low entropy? Because without that, there would be no direction, no arrow, no flow of time, just a static reality. And this is where the mystery deepens, because the early universe, shortly after the Big Bang, was incredibly ordered, smooth, uniform, low entropy, which is strange, because high entropy states are far more likely. There are vastly more ways for a system to be disordered than ordered. And yet, the universe began in one of the most ordered states possible. Why? We don't know, but everything we experience depends on it. Because as entropy increases, time appears to move forward. Memory forms, change occurs, events unfold. Without that initial condition, there would be no past, no future, no sense of progression, just a timeless existence. And this leads to a strange realization. Time may not be fundamental, it may not be a built-in feature of the universe, but an emergent property, something that arises from the way systems evolve, from the increase of entropy, from the unfolding of complexity. In this view, time does not flow, it emerges from change, from difference, from the way one moment relates to another. And if that's true, then the present may not be special. It may not be a moving point, traveling through time, but simply the point of awareness in a much larger structure. Some physicists describe this as the block universe, a model where past, present, and future all exist simultaneously, like pages in a book, already written, already there. We are not moving through time. We are moving through our perception of it, experiencing one moment at a time, but all moments exist equally. If that idea feels unsettling, that's because it is, because it challenges something deeply human. The sense that the future is open, that choices matter, that time is something we move through, rather than something that already exists. But physics does not require time to flow, only that events are ordered, and even that ordering may be more flexible than we imagine. In certain extreme conditions, time behaves differently. Near a black hole, time slows down. To an outside observer, clocks near the event horizon appear to almost stop. For the person falling in, time feels normal. But to the rest of the universe, they seem frozen, which means time is not absolute. It depends on where you are, how fast you're moving, how strong gravity is, and if time can stretch, slow, almost stop. Then what exactly is it? Is it a dimension, property, an illusion, or something even stranger? Some theories suggest that time may not exist at the deepest level of reality, that the fundamental equations of the universe can be written without time at all. Only relationships, only states, and from those relationships, time emerges as a way of describing change. Not as a fundamental ingredient. If that's true, then the flow of time, the feeling of moving forward, may be something created by our minds, a way of organizing experience, a structure built on top of deeper laws. And this leads to a profound question. If time is not fundamental, then what is reality like without it? What does existence look like when there is no past, no future, no flow? It's difficult to imagine because everything we know, everything we experience is shaped by time. Memory, expectation, change, all depend on it. But if time is emergent, then those things may also be emergent, layers built on top of a deeper reality that is timeless. And in that reality, everything may already exist, not happening, but being, still, complete. And yet, we experience it as motion, as change, as flow, which suggests that there is a gap between reality as it is and reality as we perceive it, a translation, a transformation that turns something timeless into something that feels like time. And that transformation may be happening inside us, in the way our minds process information, in the way we construct a narrative of existence moment by moment. And if that's true, then time, as we experience it, is not just a feature of the universe, and it is a collaboration between reality and perception. And that makes it even more mysterious, because it means to understand time, we may need to understand not just physics, but consciousness itself. In the next part, we begin to explore that connection between the universe and the observer, between what exists and what is experienced, and whether reality is truly independent or somehow connected to the act of observation itself. Part 10. The Observer Problem. There is a quiet assumption that we rarely question, that the universe exists independently of us, that stars shine, galaxies move, particles interact, whether we are watching or not. It feels obvious, natural, almost undeniable. But when we look deeper into the foundations of physics, that certainty begins to fade. Because at the smallest scales, reality behaves differently, not solid, not fixed, but undefined, until something happens, an observation. In quantum physics, particles do not have definite properties until they are measured. Before measurement, they exist in a superposition, multiple possibilities, at once. A particle can be here and there. A system can be in multiple states, simultaneously. not metaphorically, but mathematically and experimentally. This is not just theory, it has been confirmed in countless experiments. Perhaps the most famous is the double-slit experiment, where particles, like electrons or photons, are fired toward a screen through two narrow openings. If we observe which slit they pass through, they behave like particles, discrete, predictable. But if we do not observe them, they behave like waves, interfering with themselves, creating patterns that suggest they pass through both slits at the same time. The act of observation changes the outcome, not just what we see, but what actually happens. And this is where things become deeply unsettling, because it suggests that reality is not fully determined until it is observed. But what does that mean? What counts as an observation? Does it require a conscious observer, or is any interaction enough? Does a measuring device collapse the wave function, or does it require awareness? There is no clear answer, only interpretations. Some physicists argue that observation simply means interaction. When a system becomes entangled with its environment, its possibilities collapse into a single outcome. No consciousness required. Others suggest something more radical, that consciousness itself plays a role, that the act of awareness is fundamental, that reality does not fully exist without an observer. This idea is controversial, but it raises a powerful question. If observation affects reality, then what is reality without observers? Is it a set of probabilities, a cloud of possibilities waiting to be resolved, or is it something else entirely? Something we cannot fully describe without participating in it? This leads to a strange realization. We are not separate from the universe. We are part of it, not just physically, but fundamentally. Our observations, our measurements, our interactions help define the state of reality, which blurs the line between observer and observed, between subject and object, because if the act of observing changes the outcome, then we are not just witnessing reality, we are participating in it. And this participation may be unavoidable. Every measurement, every experiment, every observation is an interaction, a connection between us and the system we are studying. And through that connection, the system changes, which means there may be no such thing as a completely objective view of reality. Only perspectives, only interactions, only outcomes that depend on how we look. And this idea has deep implications because science has always aimed to describe reality as it is, independent of the observer. But quantum physics suggests that such a description may not exist, at least not in the way we imagined. Instead, reality may be relational, defined not by absolute states, but by interactions between systems, between observers and the observed. In this view, there is no single fixed reality, only a network of relationships, each one defining a different aspect of the whole. And this begins to echo something we've seen before. In the idea that space may be built from connections, that distance is not fundamental, but emerges from relationships. Now, we see a similar pattern with reality itself, not as a collection of independent objects, but as a web of interactions. And we are part of that web, not outside it, not separate from it, but woven into it, which raises a deeper question. If observation plays a role in shaping reality, then what is the role of consciousness? Is it just another physical process, an emergent property of the brain, or is it something more, something fundamental to how reality unfolds? We don't know. But the fact that the question exists tells us something important, that the boundary between physics and philosophy is not as clear as we once believed. That understanding the universe may require us to understand not just matter, not just energy, but awareness itself. And that is a very different kind of challenge, because consciousness is not something we can easily measure, not something we can isolate in a detector. It is something we experience directly, subjectively, and yet it may be connected to the deepest structure of reality, or it may not. And until we understand it, the picture remains incomplete, which brings us to a quiet but profound realization. The universe is not just out there, it is also in here, in perception, in awareness, in experience, and the two may be more connected than we ever imagined. In the next part, we explore one of the most radical ideas to emerge from this line of thinking, that reality itself may not be physical in the way we assume, but something closer to information, a structure not of matter, but of meaning. Part 11. Reality as information. There is a subtle shift that has been happening in physics, quietly, gradually, a change in how we think about reality itself. For a long time, we believed that the universe was made of things, particles, fields, forces, tiny building blocks, interacting in space and time. But as we've gone deeper, that picture has started to blur. Particles are no longer solid objects. They behave like waves, like probabilities, like something that cannot be pinned down until it is observed. Fields are not just backgrounds. They fluctuate, they interact, they give rise to particles. Even space, as we've seen, may not be fundamental. So if none of these things are truly basic, then what is? What lies beneath it all? One possible answer is something surprisingly abstract. Information, not matter, not energy, but information. At first, this sounds almost philosophical, but in modern physics, information has taken on a very real role. Because everything we can describe, every state of a system, every configuration of particles, every possible outcome, can be expressed as information, bits, yes or no, this or that, a pattern of possibilities. And some physicists have begun to suggest that this is not just a description, but the foundation, that reality itself is made of information. That matter, energy, space, time, all emerge from deeper informational structures. This idea is sometimes summarized in a simple phrase, it from bit, the idea that every it, every physical thing arises from bit, from information, from binary choices, from fundamental distinctions. And if that's true, then The universe is not a collection of objects, but a vast information processing system, a network of relationships, where the state of everything is defined by how it relates to everything else. This begins to connect with something we saw earlier. That reality may be relational, not absolute, defined by interactions, not independent existence, and information is the language of those interactions. When two particles interact, information is exchanged. When a measurement is made, information is created. When a system evolves, information changes. And in this view, the universe is not static. It is constantly computing, updating, evolving through the flow of information. Now, this idea becomes even more interesting when we look at black holes, because black holes present one of the deepest puzzles in physics. According to classical physics, anything that falls into a black hole is lost forever, information included, but quantum mechanics does not allow information to be destroyed. The laws of physics require that information is preserved. This creates a paradox. If information is lost in black holes, then quantum theory is incomplete. If it is preserved, then something about black holes is not what we think, and over time, a surprising idea has emerged. That information is not lost, but encoded on the surface of the black hole, not inside it, but on its boundary. This leads to something known as the holographic principle, the idea that all the information contained within a volume of space can be described by information on its surface, like a hologram. A two-dimensional surface, encoding a three-dimensional reality. If that's true, then our universe may be similar. What we experience as three dimensions could be a projection of information stored on a lower dimensional boundary. Now, this is not proven, but it is taken seriously in modern theoretical physics, and if it's correct, it changes everything, because it means reality is not what it appears to be, not solid, not continuous, but encoded, structured, built from information. And this connects back to everything we've explored. Dark matter may be a manifestation of unseen informational structures. Dark energy may be related to how information behaves at the largest scales. Space may emerge from patterns of entanglement. Time may arise from the flow of information, and consciousness may be linked to how information is processed. Suddenly, the pieces begin to align, not as separate mysteries, but as different aspects of a deeper framework, a universe, not made of things, but of relationships, of patterns, of information. And this leads to a profound question. If reality is information, then what is information made of? Is it fundamental, or does it arise from something even deeper? And what does it mean for us? Because we are not outside this system. Our thoughts, our memories, our perceptions are also information, patterns in the brain, signals flowing through neurons, which means we are part of the same structure, participants in the same informational universe, not separate observers, but embedded within it. And that creates a strange loop, because we are using information to understand information, a system trying to understand itself. And perhaps that is the deepest mystery of all, not just what the universe is made of, but how it can be known from within. Because if reality is information, why then understanding it may not just be a matter of observation, but of interpretation, of decoding, of finding the patterns that lie beneath everything we see. And as we continue this journey, we move closer to a final set of questions, not just about the universe, but about existence itself. Why is there something rather than nothing? Why does this structure exist at all? And whether there is any ultimate explanation waiting to be found, or whether the mystery itself is the answer. In the next part, we begin to approach those questions carefully, because beyond this point, the boundary between science and philosophy begins to disappear. Part 12. Why is there something instead of nothing? There is a question so simple that it almost disappears. And yet, the deeper you look, the more impossible it becomes to answer. Why is there something instead of nothing? Not why the universe looks the way it does, not why galaxies form, or why physics behaves as it does, but something more fundamental. Why does anything exist at all? Because when we step back and strip everything away, matter, energy, space, time, even the laws of physics themselves, we are left with a strange possibility that there could have been nothing. No universe, no reality, no existence, just nothing. And yet, that is not what we observe. We are here in a universe filled with structure, with laws, with patterns, which means something exists, and that something demands an explanation. At first, it seems like a philosophical question, but it reaches deep into physics, because modern theories attempt to describe the origin of the universe, the Big Bang, the moment when everything began, or at least the earliest moment we can describe. But even here, there is a problem. The Big Bang does not explain why there is something. It only describes how that something evolved from a hot, dense state into the universe we see today. But what about before? What caused it? What created the initial conditions? And this is where things become uncertain. Some theories suggest that the universe could arise from a quantum fluctuation, a spontaneous event, in a vacuum, where energy briefly appears due to quantum uncertainty, and instead of disappearing, it expands, becomes stable, forms a universe. If that's true, then nothing is not truly nothing. It is a state with potential, with laws, with the ability to generate something. But that leads to another question. Where did those laws come from? Why does the vacuum have properties that allow universes to form? Because if nothing contains rules, contains structure, contains potential, then it is not truly nothing. It is something, which means we have not answered the question. We have only moved it deeper. Some physicists suggest that our universe is one of many, a multiverse, where universes constantly form with different laws, different constants, different structures, and we exist in one where conditions happen to allow for complexity, for life, for observation. In this view, there is no single explanation, just a vast landscape of possibilities. and we are in one of them. But again, this does not answer the question, why does the multiverse exist? Why is there this structure instead of nothing? And so, the mystery remains. Some philosophers have argued that nothing may be impossible, that existence is necessary, that something must exist because non-existence cannot be. But this idea is difficult to prove and difficult to fully understand because we cannot experience true nothingness. We can imagine emptiness, but even that imagination occurs within something, within a mind, within a reality. We have no reference point for absolute nothing, and so we are left with a paradox. We can ask the question, but we may not be able to fully grasp the answer, because the question itself may lie beyond the limits of human understanding. And yet, it continues to pull at us because it touches something deep, the origin of everything, the foundation of reality, the reason for existence itself. And as we've seen, every attempt to answer it leads to deeper questions. Not resolution, but recursion, a loop, where each answer requires another explanation on which suggests something profound way, that there may not be a final answer, not because we haven't found it, but because it may not exist, because the question itself may not have a satisfying resolution. And if that's true, then the mystery is not temporary, it is permanent, a built-in feature of reality. And that can feel unsettling, to realize that there may be questions we can never fully answer, but it can also be strangely calming, because it means we are not failing to understand, we are encountering the edge of what can be known. And beyond that edge, there may be no answers, only deeper mystery, which brings us to a quiet realization. Yet the universe is not just complex, it is fundamentally mysterious, not just in its details, but in its existence. And that mystery is not something to solve, but something to experience, to explore, to sit with, because the fact that anything exists at all is already extraordinary. And as we move toward the final parts of this journey, we begin to shift from asking questions to reflecting on what it means to live inside a universe that may never be fully understood. In the next part, we explore that perspective, not just as observers, but as participants inside a reality that is far deeper than it appears. Part 13. Living inside the unknown. There is a quiet shift that happens when you begin to see the universe this way, not as something fully knowable, but as something vastly beyond complete understanding. At first, that idea can feel unsettling, to realize that most of reality is invisible, that the forces shaping everything are unknown, that space, time, matter may not even be fundamental. It can feel like the ground beneath certainty begins to dissolve. But if you stay with it, if you sit with that realization, something else begins to emerge, a different perspective. Because the mystery is not just out there, it is something we live inside, right now. Every breath you take, every thought you have, every moment you experience is happening within a reality that is mostly unknown, and yet it feels stable, familiar, almost simple. Which means there is a gap between what reality is and how we experience it. A layer of perception that filters complexity into something manageable, something we can live with. Because if we experienced the universe as it truly is, with all its uncertainty, all its invisible forces, all its unresolved questions, it would be overwhelming. So instead, we experience a simplified version, a model constructed by the brain based on limited information. And that model is incredibly effective. It allows us to navigate the world, to make decisions, to survive. But it is not complete, not even close. And this is not a flaw, it is a feature. Because understanding everything is not required to exist, only understanding enough. Enough to move, enough to act, enough to continue. And yet, there is something unique about us. We don't just experience reality, we question it. We look beyond the surface. We ask, what is really going on? And in doing so, we push against the limits of our own perception. We build tools that extend our senses, telescopes that see beyond our eyes, detectors that reveal invisible particles, mathematics that describes things we cannot imagine, and with each step, we peel back a layer, not all at once, but gradually, carefully, and what we find is not simplicity, but depth, layer upon layer, of structure, of mystery, of unanswered questions. Which brings us to an important realization. We are not separate from the unknown. We are part of it, not standing outside the universe, trying to understand it, but inside it, trying to understand itself. A small region of the cosmos, becoming aware of its own existence. And that is something extraordinary, because it means the universe is not just matter and energy, it is also awareness. Not everywhere, not in every form, but here, in this moment, through you. And that awareness changes how we relate to the unknown, because the mystery is no longer something distant. It is something intimate, something we carry with us, in every question, in every thought, in every moment of curiosity. And that changes the feeling from fear to wonder, because not knowing is not the same as being lost. It is being at the edge, at the boundary between what is known and what is possible. And that boundary is where discovery happens, not certainty, but exploration, not final answers, but deeper questions. And perhaps that is the true nature of understanding, not to eliminate mystery, but to engage with it, to move through it, to let it guide us toward new perspectives. Because every time we think we understand something, the universe reveals another layer, another level, another question. And that is not a failure. It is the process, an ongoing unfolding without a final endpoint, which means the journey itself is the point, not the destination, not the final answer, but the act of exploring, of asking, of wondering. And this perspective changes something subtle, but important. It removes the pressure to fully understand everything and replaces it with a quiet appreciation for the fact that we can understand anything at all, that we can look up at the night sky and ask questions, that we can build theories, detest ideas, explore the unknown, even if we never reach the end, because perhaps there is no end. only deeper levels. And as we move toward the final parts of this journey, we begin to shift once more from the vast scale of the universe back to something more personal, more immediate. Because in the end, all of this, all of these ideas, all of these mysteries lead back to a simple question. What does it mean to exist inside a universe like this? And how should we think about our place within it? In the next part, we explore that question, not as scientists, but as conscious beings, living inside a reality we may never fully understand. Part 14, Your Place in a Universe You Can't Fully Understand. There is a quiet shift that happens when you begin to accept that the universe may never be fully understood, not just by you, but by anyone. At first, that idea can feel unsettling because we are taught to seek answers, to solve problems, to believe that every question has a solution waiting somewhere. But here, at the edge of everything we've explored, we encounter something different. Questions that may not have final answers. Mysteries that may not be resolved. And yet, we are still here, living, thinking, experiencing, inside this vast, unfinished understanding, which raises a simple but profound question. What does it mean to live in a universe like this? Because if reality is mostly unknown, then certainty is not the foundation of existence. Uncertainty is, and yet we continue. We wake up, we make decisions, we form connections, we build meaning, not because we understand everything, but because we don't need to. And this reveals something important. Meaning does not come from knowing everything. It comes from experiencing, from engaging, from being present within the unknown. Think about it. Every moment of your life has always been uncertain. You've never known the future. You've never fully understood the complexity of the world around you. And yet, you've lived through it. You've adapted. You've learned. You've found your way, which means you are already equipped to exist within uncertainty. It's not something new. It's something you've always been doing. But now, there is a deeper awareness that the uncertainty is not just personal, it is universal, built into the structure of reality itself. And instead of resisting that, we can begin to see it differently. Not as a limitation, but as a space for possibility. Because if the universe were fully known, fully predictable, fully understood, then everything would be fixed, determined, closed. But it's not. There is openness, room for emergence, room for change, room for new patterns, new ideas, new experiences. And that openness is what allows life to exist, what allows consciousness to arise, what allows you to be here. So instead of asking, how do we eliminate uncertainty? We might ask, how do we live within it? And perhaps even appreciate it, because uncertainty is what makes exploration possible. What makes discovery meaningful? What makes each moment something that has not yet been fully defined? And in that sense, your place in the universe is not to fully understand it, but to experience it, to participate in it, to be one of the ways the universe becomes aware of itself, not as a detached observer, but as an active presence living within the unfolding. And that changes the perspective, because instead of seeing yourself as small in comparison to the vastness of the cosmos, you can begin to see yourself as part of it, not separate, not insignificant, but connected, made of the same elements, shaped by the same forces, existing within the same mystery. You are not outside the universe looking in, you are the universe looking at itself in one specific form, at one specific moment, and that moment is enough. It doesn't need to contain all answers. It doesn't need to resolve every question. It only needs to be experienced fully, quietly, with awareness. Because the fact that you can ask these questions, that you can reflect, that you can wonder, is already something extraordinary. A rare configuration of matter and energy, capable of awareness, inside a universe that may never fully understand itself. And yet, here you are, thinking about it. Which brings us to a final realization. Understanding is not just about answers, it's about perspective, about how we relate to the unknown, whether we see it as something to fear or something to explore, something to resist or something to accept. And perhaps the most meaningful shift is not in what we know, but in how we see. Because when you look at the universe through this lens, it stops being a problem to solve and becomes an experience to live, a mystery to move through, a story that you are part of. And as we move into the final part of this journey, we begin to let go of the need for resolution and settle into something quieter, a kind of calm understanding that not knowing is not the end of the journey, it is the space where the journey continues. Part 15. The quiet acceptance. There is a moment that comes after all the questions, after the searching, after the theories, after the realization that the universe is far more mysterious than we ever imagined. It is not a moment of conclusion, not a final answer, but something quieter, a kind of stillness where the need to solve everything begins to fade, and in its place, something else appears, understanding of a different kind, not the kind that explains everything, but the kind that accepts that not everything needs to be explained. Because by now, you've seen the pattern. The deeper we look, the more reality expands. Dark matter, invisible, yet essential. Dark energy, driving the universe apart. Space, not empty, but structured. Time, not flowing, but emerging. Reality, not fixed, but relational. And beneath all of it, a question that may never be answered. Why is there something instead of nothing? Each layer revealing something new, but never revealing everything. And that is not a flaw. It is the nature of the universe itself. An open system, not a closed book, which means there is no final page, no last chapter where everything is explained, only an ongoing unfolding. And within that unfolding, there is a place for you, not as someone who must solve the universe, but as someone who can experience it. Because in the end, that may be the most important part, not the equations, not the theories, not the answers, but the experience of being here, right now, in this moment, aware, because awareness is something extraordinary. In a universe that is mostly silent, mostly unaware, There are small pockets where reality becomes conscious, where it reflects, where it asks questions. And you are one of those places, a brief but meaningful expression of the universe becoming aware of itself, not forever, not infinitely, but for a moment, and that moment is enough. It doesn't need to last forever, to have meaning. It doesn't need to contain all answers, to be complete. It only needs to be lived. And when you see it that way, something changes. The vastness of the universe stops feeling overwhelming and starts feeling peaceful, because you are not separate from it. You are part of the same process, the same unfolding, the same mystery. And the unknown is not something outside you. It is something you are already within, which means you don't need to reach the edge of the universe to encounter it. You are already there, right now. In every question you ask, in every moment of curiosity, in every quiet realization that there is more than you can ever fully understand. And instead of resisting that, you can rest in it, not as ignorance, but as openness, a willingness to exist without needing everything to be resolved, because the universe does not rush to explain itself. It unfolds slowly across billions of years, and within that vast time scale, your life is brief, but not insignificant, because significance is not measured in duration, but in experience, in awareness, in the ability to perceive even a small part of what exists and to reflect on it, to feel it, to wonder about it. That is something rare, something meaningful, even in a universe where most things remain unknown. And so, as we come to the end of this journey, there is no final answer to give you, no single truth that resolves everything. Only this: you are here, in a universe that is vast, mysterious, and unfinished. And within that universe, you have the ability to experience, to question, to explore, not forever, but now. And that is enough. So, the next time you look up at the night sky and see the stars scattered across the darkness, remember this: you are not looking at something separate. You are looking at the same universe that made you, the same reality that you are a part of. And even if you never understand all of it, you are still connected to it, still within it, still part of its story. And maybe that is the closest thing to an answer we will ever have. If this journey into the unknown helped you slow down or see the universe in a new way, take a moment to support the channel. Subscribe so you don't miss the next exploration. Leave a like if you felt even a small sense of wonder. And if there's a question that stayed with you, let it stay. Because sometimes the most powerful thing we can do is not to answer a question, but to keep it alive, quietly, in the background of our awareness, as we continue through this vast, unfinished mystery